Hello. Thank you for being here, and thank you, AltConf, for having me. I'm Erick Camacho, and I'm going to talk about Xcode build and test logs. A bit about me. I work as an iOS infrastructure engineer at Spotify. And one thing I really like about iOS is the community, because in the iOS community is really good at sharing knowledge. There are people who wrote a lot of blog posts, post videos, post tweets on Twitter, and have written a lot of open source projects to help us. And in this talk, I'm going to talk about a journey of marvels and mysteries inside Xcode internals that me and my team did to understand how Xcode build logs works and are generated, and what kind of information is inside those logs. And when I talk about Xcode logs, what I really mean is about this tool that is built inside the Xcode IDE that is called the Report Navigator button. So I'm sure you have used that. You have used that screen. After you build your project, or after you run your tests of your project, you can go to that screen and see a lot of information regarding what happened. So there is a lot of data on that screen. You can see not only how long did it took to build your project, you can see how long did it took to build each file inside your project, or you can see which scripts were run in the build phase scripts, or you can see which warnings were thrown by the compiler, or which warnings were thrown by the project. You know these warnings that, hey, you maybe want to move to a suite 5, for instance. And if you run tests, you can see not only what happened for the test, I mean, if it passed or if it failed, but you can see more information. For instance, if you are using Etsy UI test and the test fail, you can see even the screenshot of the test when that test failed. So it's really impressive. I really liked what Apple did with this screen, and it's really useful. I mean, sometimes you spend a lot of time just trying to understand that information. And the report navigator is good. It's really good, but it's only enough if there is only one developer in your team. For instance, what happens if a colleague checks out the project after you merge a commit, and then she fails to build your project? So she will reach out to you like, hey, I just check out your changes, and now the project is not building. And how can she share the information about what happened in her machine with you? Well, usually you take a screenshot of that report navigator, or you try to copy and paste that error message and share it with via Slack or whatever messaging system you are using. So that doesn't scale good. At the moment you have more than one developer, report navigator is not good enough because it's just constrained inside the IDE. So in my infrastructure team, we were thinking about that. I mean, we really liked the data that we have. How can we extract that data out of Xcode? How can we build some other tools around that data? And by the way, a small parenthesis, Xcode 11 beta was released this Monday, and they have now a new option. In the report navigator, they have this export button, or if you are using command line, there is a new command called xcresult tool that with the export button, you can export a summary of that report, of the report inside the report navigator as a text file. And with the xcresult tool, you can export the same summary, but as a JSON document. So it's good. It's really good that Apple is trying to do to provide us with that kind of tools. But the problem is that it only contains a summary. So yeah, you can see how long did it take to build your project or to run your test, but you cannot see the detail of what happened inside your build or inside your test. But it's good that Apple is doing that. And something that has happened in the iOS community is when we don't find the official tools from Apple, we build them ourselves. So a good example is Fastlane. We needed, as a community, a way to automate some process that had to be run manually. Like, for instance, how can I regenerate a provisioning profile? How can I renew a certificate to sign my app? And Fastlane, this open source tool, they did some hacks to call unofficial private Apple APIs to do it, and this year finally we have an official API from Apple. But the thing is, we didn't have to wait until Apple had the time to provide us with that kind of tool. We did it ourselves in the meantime. And yeah, it was hacky, it wasn't not that stable, but it worked, and most of the projects have been using that for some years. And so in my team, we started to think, okay, this is a common problem when you are dealing with infrastructure of mobile projects. So what happens in other platforms? What happens outside the Apple ecosystem and the iOS ecosystem? So we take a look to Android land, and in Android land, that is a solved problem. So in Android, by default, they use a tool called Gradle to build the projects. You can change that build tool, but by default, this is the most used tool. And they have a feature, a really nice feature that is called build scans. So if you build your Android project with a scan flag, what Gradle does is that it generates a computer-readable document with all the information that happened while your project was being built. So if you have this computer-readable format, you can do a lot of things. So Gradle, when you pass this scan flag, it generates that format, and that document is uploaded to Gradle public cloud. If you buy a license of something that they call Gradle Enterprise, you can have a build server, a build scan server on your premises. So it's more private, but I mean, it's a solved issue. And once you have that, once you have the build information or the test information in a computer-readable format, you can build some amazing tools. This is like the web app, the Gradle build, to analyze those build scans. So you can see that you can have stuff like the summary, the log of the console. You can have the timeline. This is the timeline. You can see all the steps that were run while your Android project was being built. You can see information about the tests. You can see information about the plugins installed, about the infrastructure. That's how they called the local environment of the developer. So what happened in that scenario I was telling you about, that, OK, someone tried to build the project after you merge a commit and it's not being built. It's having some issues. So instead of sharing a screenshot of the IDE of copy-pasting the error from the console, they can share you the link to the build scan. And then you can go and take a look and probably see, OK, this is not an issue about the code. Probably you have to update this plugin because it's needed to run the new feature. And also, another tool that is built inside this Gradle build scan web app is a tool where you can see the aggregated results of all the builds that have happened in your project. So you can have a nice timeline of the build times, for instance. And you can see, OK, there was a spike last Wednesday. Since last Wednesday, now our project is taking 5 minutes more to be generated. So it's really easy to spot. It's really easy to analyze all that data. So to be honest, I was really impressed when I see that. And my team was really impressed as well. And we started to think, OK, there should be a way to do it the same for Xcode. How can we have a computer-readable format of the report navigator data? And I started to look at this problem as a side project. And the first clue is that there is a log generated by Xcode. And thanks to Michelle Titolo, I found her blog, where she writes about those logs. So what is happening inside Xcode is after you build and you run or your tests in Xcode or in Xcode build, is the same, where you are using the IDE or the command line tool. After that finishes, all that data that is being shown in the report navigator is being dumped by Xcode in the derived data folder of your project. So we have two folders. We have a logs/build folder and a logs/test folder. And that happens a few seconds after the build or test finishes. It's a few seconds, obviously depends on a lot of factors. So the best strategy is that you can monitor those folders, and when a new log appears, then you can process them. And the structure of both folders is different. So the first one is the build folder. It's really simple. They have a plist file that is called log store manifest. And then they have a collection of etc activity log files. Those etc activity log are the logs of Xcode. And every time you build your project, one of those is generated. And just be aware that those logs are periodically deleted by Xcode. You won't find a lot. Usually you will find the last 3 or 4 logs, and that's it. So if you want to save them, you will have to copy them into another location. The test folder is a bit more complex because basically the test generates another format that is called XCC result. And it's a folder with this structure that has a bunch of artifacts generated by your tests, like the attachments. The attachments are those screenshots if you are using XCUI that are generated when your test fails. And then you have two etc activity logs, one that is called build, and that has information thrown by the compiler where your test target, when your test targets were built. And the second one is action.etc activity log that has information about what happened when you run your test. So those are the artifacts that are generated. This plist, the log store manifest, is a really good way to understand more about what's happening in your log folders. And they basically show the logs that have been generated, the timestamp when that log was generated, and also a description, a short description of what that log is about. So it will say something like, OK, this is the log when this test suite was run, or this is the log when you clean your project, or this is the log when you build your project, and stuff like that. So this is a pretty good starting point. If you just open this, it's a plist file. You can open it with Xcode or even with a text editor. But what about those etc activity log files? That etc activity log file is actually a gzipped file, so you can just uncompress it. And once you uncompress one of those files, you will find that there is a file encoded in a format that is called SLF. So if you open that in a text editor, it looks like this. So yeah, you can understand that this is a log. There are some strings there. There are also some numbers, some weird characters. So that's what we found once we start looking at what was being generated by Xcode. And then we found a second clue, thanks to Vicente Isambard. Vicente Isambard wrote this blog post back 2 years ago in Japanese, because he lives in Japan. But I mean, you can use Google Translate to understand it. And basically, he explains how this format works. And he based his findings in a Haskell script that he found in GitHub without documentation. So I do not know Haskell, but he does. And he wrote a Ruby script to do the same and explain more about the format. So this format is Xcode's very own undocumented encoding format. So you will find that if you open, you can detect if the file is encoded in this format because of the header. So the header are these 4 characters, SLF and the number 0. So then you can assume, OK, this is a file encoded in that format. And the rest that is encoded into this format is a collection of data with these types. So you have integers, array, class names, class instances, nil values, and so on. So this is how the encoding, SLF encoding works. You have a value that is optional. Then you will have a character that Vincent calls it the type delimiter. So that character will tell you what type is that value that is encoded. And then you can have at the right-hand side value that is also optional. So this is the integer. The type delimiter is the £. And this is an example. In this case, 10 is the left-hand side value, and then the £. So basically, that's how you encode the number 10. And then for the double, it's pretty similar. The type delimiter is the caret, and the number is in hexadecimal, but this is a double. As a tip, in all the doubles inside the etc activity log files are time intervals since reference date. They are timestamps since 2000, in the year 2000 or 2001, I forgot. So when you found a double, it's actually a date, a timestamp. The nil is the only type that doesn't have neither a left nor a right-hand side value. It's only a dash. So if you found a dash, that's a nil value. And the string has the type delimiter double quote. And the left-hand side value is the length of the string. And the right-hand side value is the actual string. So basically, what you have to do is, if you found an example like this, you found 5, you start counting 5 characters after the type delimiter. And this is not Unicode, so some characters will count like twice or thrice, because SLF is not using Unicode format. So in this example, the string is hello, but sometimes you will find something like this, seeds, and then hello, dash, dash. And the string is actually hello and dash. The other dash is a nil value. So that's why this format gives you the length of the string. So you can know, OK, this is not a dash, that is part of the string. This is another type, in this case, a nil value. And then you have arrays. The arrays uses the left parenthesis as a type delimiter. and the left-hand side value is the number of items in the array, is the count, basically. So in this case, the encoding format is telling you that this array has 20 items inside. And then we have the last two types. One is called class name, or type. You can also call it type. The type delimiter is the percentage sign, and it's pretty similar to the string. The value at the left is the number of characters that you have to count to get the class name. In this case, the class name is ID activity log section. And this is really interesting. A specific class name only appears once in the log. And the thing you have to do to parse the log is that you will have to store that in an array. Because what it's important about the class name is to know the index used in the log for this class name. So the first class name that you will find is index 0, the second index 1, and so on. And that index is really useful to parse the last type of the format that is the class instance. So a class instance is the actual instance of a type. And it uses this @ sign. And you can see that this is an example. You will find something like a number and then the @ symbol. And that means that this is an instance of the type with the class name that you found with the index 1. So the second class name that you found in the log. So you will have a lot of class instances, but the class name will only appear once in your log. There could be several class instances in a log. So basically, a log is a collection of class instances. And all the values after a class instance could be properties or instance variables that belongs to that instance. So after having that knowledge and after some tests, we were able to tokenize the logs. So we transformed something like this into something like this. So this is the actual log, an actual log. So the first value is the only one that is not encapsulated in a class instance because that's the version of the format that this log uses. In Xcode 10 and Xcode 11, we are using the version number 10. Xcode 9 used the version number 9. 9.4, Xcode 9.4 used the version number 9. Xcode 9 used the version number 8, and so on. So you always have to take care of that. And the rest is the content. So in this example, we found the first thing that we found was a class name that is called ID activity log section. And after that, we found a class instance of that type. And then we found a lot of values, like an int with value 0, a string, another string, a double value, a list with 11 elements inside. And then we found the first element that is also an instance of ID activity log section, and so on. So one thing about the format is that it tells you when a class instance starts, but it doesn't tell you when a class instance ends. So you have to do a lot of assumptions about that. And the next step was, how can we deserialize these classes? I mean, we have like the values. Okay, we have an int with value 0, and then here we have an int with value 1. What does that mean? What's the name of that property? I mean, it's a 0, 1. Yeah, and we have some strings that, yeah, this looks like a title, isn't it? And then we have a string repeated. What's the name of that property? How can we know that? So the first thing I did was to list all the class names that we found on the logs. So these are the class names that you can find in build and test logs. And it's in Xcode 11, they added these two. And then I started to look for information about those classes online. And that was my third clue. So thanks to Luis Ovo, who back in the days of Xcode 7, he class dumped all the private frameworks of Xcode and then published that in a GitHub repo. So when I was trying to find information about those classes, I found the headers in that repo. So thanks to Luis Ovo for doing that. He did it for other reasons, but it was helpful for me. So I did the same. I class dumped the current Xcode headers for Xcode 10, 10.1, 10.2.1, 10.2.0, and Xcode 11. That's the current one, 11 beta, to start analyzing the headers of those types. And the final step was a really tedious and error-prone step. So basically, I started by picking a class, the class with less attributes, and I tried to match the values to the instance variables of that type. So for instance, I found an int with value 0, and I found that for that given class, the first property in the header was an integer called the status. And I found that that int in other instances of the same class had a 1. So sometimes it was a 0 or a 1. So it kind of makes sense that that's the status of that, of that type. So it was like that. Sometimes it was not really straightforward. So I needed to find more logs and do more tests with those logs. So it basically felt like this, like trying to catch an ever-changing Pokemon for a while. You are like, OK, this is it. I just nailed it. And then you found a log that crashes your parser. So it took a while to figure it out. I started doing this like in October last year. And the thing I was trying to build was a tool to benchmark our builds inside my organization. And by coincidence, the fields that are related to the build times are the first in the classes, are the first fields. So I found out those, and I forgot about parsing the other fields because it was just a lot of work. But this year, I just finished the job. I was, OK, I know what I have to do. I just need more time to do this kind of tests. So that's how me and my team finished this tool. We call it xclogparser. So xclogparser is a command line tool to parse these Xc activity logs. It's written in Swift and is using the Swift package manager. So you can use it as a command line tool from your console, or you can import it in other Swift projects if you want to just use it as a dependency. So let's see how it works. We're going to see first a command that we called dump. So I'm going to switch here. Give me a minute. OK. I'm going to mirror my project. So the thing I did was to find out, again, thanks to the community, open source iOS projects. So this is a project called Artsy that is done by the Artsy company. They publish everything they do as open source in the repo. So it's a production-ready app, and it's a very large app. It has a ton of code dependencies, as you can see, and it has a lot of code. It's written in Objective-C. And what I did was basically I compiled the project. I did a clean build of the project. And this is the report navigator. You can see all the information that is generated by the report navigator. It's a lot. You can see that first it starts to run this prepare build phase, put some comments here using the build system, planning the build. Then it has a lot of warnings about the build system. And then it starts building some targets. The first target is the AEF networking library, then the target Artsy and so on. So after you do this, after you build your project, you can go to command line and start using xclogparser. So you can just grow xclogparser, and you can put the command called dump, and then you can specify the path to the Xc activity log if you know it. But it's usually you just want the latest, the most recent log. So you can put the flag project and the name of the project. You don't have to put the whole name, just the first letters is OK. And basically, this command will try to look in the derived data folder in your machine for a project that starts with this word, Artsy, and it will try to parse the most recent log found on it. So this is it. So this is the same information I show you in JSON format. So I'm gonna open it here, so it's a little bit clearer. This is the Artsy dump. So this is the exact information that is encoded in the Xc activity log. What this dump command does, it just dumps everything into JSON format. So it's human and machine readable. You can see here, this is the main section. The time started recording, as I told you, is a double. Then we have this what's fetched from cache, the title, domain type, something that is called the signature. Then it's a tree, basically, so it has a bunch of subsections. So then we have the first subsection that has this subtitle, workspace Artsy scheme Artsy destination iPhone X. And then you have a note using new build system, planning build. As you can see, those are the same comments that we saw on the report navigator. And it's a lot of information you can find, for instance, if you look for compile C, the information about the compilation of a specific file. So when this file was compiled, this UIB controller extension, the signature that was used to compile it, all the stuff like the architecture, it is Objective-C, and even the command detailed description should be at some point here. So you can see all the flags that were passed to the compiler and stuff like that. So basically, the dump command dumps everything into a JSON format. So now it's human and machine readable because we're using JSON. And it's a lot of data, but it's not that well organized. We can do it better. Basically, you have to transform a lot of the data to have some meaningful information. So the next thing we did in my team was to build a parser. So this parser, I will show it to you. So it works in a similar fashion. Instead of dump, you specify the parse command and the project. You can specify a reporter. So that's the format that will be used by this parse command. And then it generates another version of the same data. So let me show it here. So what we did with this parser was to provide more meaningful information about the structure of the data contained in the log. So you can see here, at the beginning, we have all the warnings inside the whole project is 50, the duration in seconds, 40 seconds, so you don't have to calculate the duration anymore. The end date now is in a human-readable format, but we also have the timestamp in units epoch, not more time intervals in reference date stuff. And then the identifier of the machine where this was run. And then you have also a bunch of sub-steps, so it's also a tree. But now we have sub-steps that are somehow typed. So you can have this type field, and you can see that this was a target that is called prepare build. And then you have an array of nodes that are those comments using new build system, planning build. And you can see, for instance, a project warning. So now we classify the warnings. In the other version, all the warnings, all the errors, or the comments are inside that structure called a message log. But here we have it specified as a specific warning type, as a specific error type, and so on. And if you want to see the files that were compiled, we have a subtype that is called detail step type. So you can find that it was a C compilation. We have Swift compilation, nib compilation, storyboard compilation, Swift compilation, running a script phase. So it's really easy to aggregate the data. So if you want to analyze only what happened when you run your build scripts inside the phase script phase, you can just filter them by this type. And then you have the title. And you can see, in this case, this file didn't have a warning, but you can see the warnings thrown by this specific file as well. And here is another example. This is the Artsy app. Other app I use for testing this is the Kickstarted iOS app. It's also a huge app. And this one is made with Swift 3, apparently, because we have some warnings regarding that. Swift 3 mode has been deprecated. And it also uses a lot of dependencies like Alamo Fire iOS, Alamo Fire image. But a cool thing about the Swift compiler is that you can go to the build settings, and you can specify a Swift flag or a bunch of Swift flags, like these ones. Warn long function bodies, and then you pass a millisecond. In this case, this is 1 second. So basically, the compiler will throw a warning if the compiler finds a Swift function that it takes more than 1 second to be compiled. So that's a pretty good thing. And the other good, interesting flag is this one, the bug time function bodies, that basically the compiler will throw into the log the information about how long did it took to compile each Swift function. So you can have a lot of granularity about your build times. And when I did that, when I ran the same for the dump, when I dumped that information, I will show it to you. It's going to take a while because it's a lot of data. You will see that the Swift compiler team did like a hack to store that information. So let me look for Swift compile. Yeah. So this is a step when a Swift Swift was compiled. No, this is not. Let me just look for another one. If I look for a Swift file, yeah, probably this one will work. Let me just look for an example of a Swift file that was compiled. This is a project auxiliary file. Compile Swift. It's a lot of data here. That's why we build the parser, because it's really hard to spot something in this format used by Xcode. But what it's doing is that, I wanted to show it to you, but basically it's creating in this text field. In that text field, it puts a whole string with all the Swift function times, using tabs and using spaces, so you have to parse those with a regular expression and so on. And not only that, it's duplicating the information in every Swift file that you compile. So you have really large strings inside the DOM, so it's not feasible to do it with the DOM. But if you parse it, so this is a parse JSON. You can see if you look for the Swift compilation. Oh, it's better if I just Swift function times. Yep, you can see that for this specific UI scroll view lenses file, we have an array of Swift function times, and we have the list of all the functions inside this file with the duration in milliseconds. So this specific closure that is at the line 25, it took 0.19 milliseconds to be compiled. Or this one, the getter, the acceleration rate, it took this amount. Or this one, the is scroll enabled, it took this amount, and it starts in the line 43. So now it's really easy to parse that information. And once we build that, we were able to build some nice reporter on top of that JSON representation. So the first one is called JSON array. It's a really simple reporter. So basically, the original JSON document that we generate is a tree. But when we were trying to dump that tree into a database that supports JSON to start doing some analysis of the initial analysis of the logs, we found out that it's kind of hard. So with this command, with this reporter, you can use a flat JSON, an array, not a tree. So it's easy to dump this into a database and just start playing with it. The second one is called Chrome Tracer. So basically, you specify -- reporter and Chrome Tracer. You can specify an output where you want to store that JSON file. And then you can use the Chrome tracing tool to analyze your logs. I'm going to do it here. So I did the same for the RC project. So this is how the Chrome tracing tool looks. You can see all the steps that were inside your build timeline. So it's a tool to analyze timelines. It is used internally by the Chrome team to analyze web apps, and it's used by Google in Bazel to do the same that I'm doing here, to analyze the build timelines. So that's where I took the idea from Bazel. So you can see that, okay, the build target AF networking was run, and then you can see, okay, and that this file was compiled, and in parallel, the compiler was compiling the target analytics. So that's really cool. All these files in analytics, you can use the arrow to see which files. So you can select this, and you can see all the files that were compiled at that exact point of time in parallel. So that's really impressive by the compiler. And then you can click on one and see more information. Okay, this was a sync compilation, and this was the command being run. And you can see dependencies on your timeline. Okay, this target, the tiled image view, was started to run after these other two targets, so probably there is a dependency. And this is the main target, the RC folio. You can see that it starts here, but then everything is compiled up to here. So probably there are some dependencies here. So it's a really useful tool to doing that. You have this tool to move with. You can pant. I always forget how to do it. Oh yeah, like this. To see more information about what's happening in your build. And finally, there is a new reporter that we built that is called HTML. So you just pass the reporter HTML, and I'm going to show it to you. So let's analyze the Kickstarted project. So project, Kickstarted, yep, reporter. I don't want to a specific folder to store this, so I'm going to remove that. This specific project is kind of a bit slow to generate because it has this Swift function information in it. So that's something that we need to improve. So let's wait a bit until this is generated. And that's it. And now we can open the report. So this is the report being generated by the tool. You can see here, okay, it's a CLog parser, the project, the schema that was run, the build status, in this case was succeeded, the build time, how many targets were built, how many C files does the project contains, how many Swift files, how many errors, in this case were 0. We can see the warnings, 3 warnings. One is about build system information. So Swift 3 mode has been deprecated. But one, I think, is an actual compiler warning. So the global function setting group table view style took 4 seconds to compile. So something's wrong with that function. And then you can see the link to go to that file. And here is a timeline. It's not as good as the Chrome tracing thing, but it's pretty good to start analyzing what stuff did run in parallel. And then you have the slowest targets, or even the slowest Swift files compilation. So this specific file took 39 seconds to compile. So sounds weird, isn't it? So if you are like, this specific target took a while, 119 seconds, you can click on it, and you will open that specific target. So now I'm inside this target. And then you can see all the steps being run inside that target. And also, you can see that the step that it took the longer was to compile the assets catalog. And if you are thinking about, OK, what's happening here, what it took 39 seconds, you can click on it. And you can see more information about that specific step. And you can see the Swift function times. So you can see that this specific function took 61 seconds. So probably it's something that you should care about. And the good thing about having this in this format, in a JSON format, is that you can also build some tool to automate that kind of analysis. You don't need to do it by hand. It's good if you just generate the HTML report and you start analyzing what's happening. But it's better if you build some tools, like, for instance, in your CI, to start rejecting PRs if something like that happens. Like, I'm not going to do that. Please fix it. You can also build benchmark tools to start ingesting those build times into a data pipeline and have some nice tools to analyze it. And so you can get it now. It's open source in our Spotify organization. If you go to the Spotify GitHub, you will find it under the xclog parser URL. And basically, the reason why we open source this is because we need your help. We are reverse engineering an obscure format, so the more data we have, the better. And we also want to have some feedback about what do you plan to use it for, so maybe we can add more features. And also, we are looking for contributors. And thanks to the team that built this, my team at Spotify, Patrick Balestra, Hassan Belhabib, and Anton Lazarev. They've been helping with code, beta testing this, building tools, internal tools in my organization around this tool, and especially to Patrick. Patrick was the one who really pushed to open source this to give something back to the community. So thank you.